dear listener, we want to quickly learn how to obtain the values of some special angles in trigonometry. So we shall be considering angles 30° and 60°. For angles 30° and 60°, we make use of an equilateral triangle, a triangle with equal sides. So we choose 2 units for each of the sides. So what we do is that bisect the equilateral triangle. Of course, for an equilateral triangle, all these angles are 60° each. So this is 60, but this will now be 30, this will be 30, and this is 60. So when you bisect it, this side becomes 1 and this side becomes 1. So we pick one of the, by bisecting it, we obtain 2 different angles, 2 different triangles. So let's pick one. This triangle, this is 90, this is 60, this is 2, this is 1. This side, let us use Pythagorean theorem to obtain its side x. Pythagorean theorem states that the square of hypotenuse side is equal to the sum of the squares of other sides. In that case, we are going to have 2 square equals x square plus 1 square. Isolating x square, we are going to obtain 2 square minus 1 square. Then x square equals 4 minus 1, which is 3. Then x is going to be root 3. So, having obtained the third side, we can go ahead now to get the values of the 6 trig functions for angle 60°. So let's start with sine 60. Sine 60°. Sine 60°. Don't forget SOHCAHTOA. We are going to be applying SOHCAHTOA here. For SOHCAHTOA, sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, and tan is TOA, opposite of adjacent. So let's start with sine, which is so opposite of hypotenuse, opposite over hypotenuse. Then before we proceed on that, how do we identify the opposite or the adjacent side of this right angled triangle? Now we are considering angle 60. Then this side will be our opposite side, this will be hypotenuse, and this will be adjacent. Don't forget, we have obtained our x to be root 3. So we can now go ahead and write out the values of the 6 trig functions for 60°. Now, opposite of hypotenuse, the value for opposite when you are considering 60° is root 3. So that would be root 3 over hypotenuse 2. Then cosine 60° is going to be, we say it is CA, that's adjacent over hypotenuse, SOHCAHTOA, CA. So adjacent side is 1, then hypotenuse side is 2, so 1 over 2. Then for tan 60°, tan 60° is going to be opposite over adjacent. Don't forget that is TOA. Tan is TOA. the opposite side is, you can see from the figure, is root 3. The opposite side is root 3, and that will be root 3, and then the adjacent side is 1. So we are going to be having this one as root 3. So let's obtain their reciprocal. So for cosecant 60 degree, cosecant, which is written as CSC, cosecant 60 degree, that's is the reciprocal of sine 60 degree. So that's going to be 1 over root 3 over 2, because we have obtained our sine 60 to be root 3 over 2, so which is a 2 over root 3. You don't leave root sine as your denominator, so you rationalize. That's going to be 2 over root 3, multiply both top and the numerator and the denominator by root 3, so it's going to be 2 root 3. We're going to have 2 root 3 over 3. 2 root 3 over 3. So then let's go for secant, which is written as secant 60 degree. That's the reciprocal of cosine 60 degrees. So it's going to be 1 over, we have obtained the value of that as value of cos 60 degrees to be 1 over 2. So 1 over 2, reciprocal of that is going to be 2. And finally, cotangent, which is written as cotangent 60 degrees. So that is the reciprocal of tan, reciprocal of tan 60 degrees. Then we have 1 over, we have obtained tan 60 degrees to be root 3. So it's going to be 1 over root 3. And then you don't leave root sine as your denominator. So we rationalize. That's going to be 1 times root 3 over root 3, which will give us times root 3, which will give us root 3 over 3.